Introduction to Edge Data Center for IoT Platform. I am Dr. Rajiv Mishra from IIT Patna. So, the content of this lecture is as follows. So, we will introduce you to the current demand of data centers, and then we will also talk about the data centers moving to the edge. So, paving a way to a new kind of data center called edge data center. In this lecture, we will also discuss the brief introduction to the cloud computing and its focus on various aspects such as why cloud, what is a cloud, what is new in today's cloud, and also what distinguished the cloud computing from previous generations, and now introduce about the edge computing uses. So, let us start with the motivation of this particular lecture of edge data centers. Now, what we have seen is the evolution of the cloud and also the waves of the innovation, and that we will see in the cloud, IoT, edge and ML scenarios. So, what you see is that this cloud has become a highly available centralized set of resources with an unlimited compute resources and the storage and network resources. Now, this particular development where the cloud is considered to be highly centralized but globally available resources often requires new innovations in the cloud due to the fact that new kind of applications such as Internet of Things is also supported by the public cloud. Lot of IoT devices start connecting to the cloud for sending their data, called streaming their data, for doing the processing, storage and other aggregations. So, these are all managed by centralized cloud. So, if you see the current state of the cloud, that is nothing but highly centralized set of resources. Often this cloud is resembling the client server computing or model, and the compute earlier which was considered in the cloud in the form of virtual machine is going beyond that, and now it is introducing or innovation is in the form of containers, and which becomes the mainstream in the cloud. Storage in the cloud is also being changed, that is complemented by content distribution network which are replicated and cached at various edge locations for efficient accessing this particular web resources through the web. So, network stack also is programmable, and software defined network is the technology which enabling the hybrid kind of scenarios. So, with this current state of cloud and allowing this lot of IoT devices to connect to the public cloud for computing and processing, and also these harnessing the signals from sensors and IoT data which is fully managed by the cloud. But this IoT, after so much of use, it has realized that not everything need to be done at the cloud, thereby realizing a way of for the edge computing. So, edge computing is a wave of innovation which is evolving around the cloud, which is also around development around the IoT use case. So, IoT requires the data which is to be streamed to the cloud earlier for doing the computation, analysis and taking up the insights. So, what is being found by IoT applications is that not every data is required to be sent to the cloud because of several reasons, that it is going to add the round trip delay when the data is sent to the cloud for making the computations. So, therefore, many applications which is a real time applications which cannot be supported in an IoT cloud model, thereby it requires that IoT data need to be processed very close to the device, and that introduces the edge computing. With the advent or with the rise of artificial intelligence, what is being found is that the machine learning models often trained in the cloud due to the several reasons such as the availability of CPU, GPU and FPU. There are many other processing units which are available at the cloud at a lower cheaper cost. So, this becomes an ideal destination to perform the machine learning model training in the cloud. Now, once the models are trained, then for inferencing part it can be now deployed to the edge for inferencing, thereby able to process or doing the inferencing very close to the device by the edge. So, this is the development which is also we are termed as the waves of innovation. So, the development of the cloud has paved into the application or the industries or manufacturing unit to use the cloud for streaming the data and doing the analytics. Now, the data has to be sent to the cloud, thereby round trip time is being added and lot of bandwidth is also used in this particular process. IoT application, they realized the need of edge between the cloud and the IoT edge. So, when you say edge, that is the network edge. So, that is out of the cloud. If all these compute resources or computing capabilities which cloud used to do, if it is available at the edge, that is very close to the IoT devices, that will now pave a way of reducing this latency. Low latency applications can be supported, and also performing the machine learning on the cloud was the standard because of the availability of CPU, GPU and other processors to do the machine learning training. Once the model is trained, then it can be deployed in the edge for the computing. So, for the inferencing, so thereby lot of innovations you can see and paving the way of a new technology which is called an edge computing, which is the evolution of the cloud. So, let us go ahead and see the edge computing. So, edge computing makes the cloud a truly distributed, and then most of the core will be now of the cloud services now be available at the origin of the data. Now, this edge mimics the public cloud platform capabilities, and thereby it will deliver the storage, compute and network services locally. It also reduces the latency by avoiding the round trip to the cloud for performing the computation and inferencing. This brings into data sovereignty by keeping the data where it belongs without any breach of privacy. Similarly, it will also save on the cloud and bandwidth usage if the data is not streamed to the cloud, but it is processed very close to the cloud, that is at the edge. So, giving away to the edge computing. Now, let us see what are the functionalities required for edge computing to be enabled. So, the data ingestion and machine to machine brokers for data ingestion from the IoT devices, which was earlier done by the cloud. Now, these functionalities are available at the edge, thereby paving away this functionality or mimic this functionality from the cloud to the edge. Similarly, the data storage, which was earlier used to send to the cloud these IoT sensors, now for storage, now that is also possible to be done with the help of edge computing, whatever is the data which is available. So, function as a service is also, that is the compute is also available at the edge in the form of containers. Machine learning model inferencing can be deployed, distributed computing model can be created in this using the edge computing, and also various databases like NoSQL and time series databases can also be supported with the edge computing. Stream processing is nothing but it is also called a hot data analytics. So, this kind of functionality which was earlier there with the cloud is now possible to be brought into the edge and performing the applications of this kind of analytics at the edge very close to the source. Machine learning models uses normally this kind of specialized processor, CPU, GPU, FPU and so on, and thereby the cloud was the de facto destination for performing the training, or it is called the learning part of the machine learning models. Once the models are trained, that is machine learning models are trained on the cloud, then they can be deployed at the edge with the help of containers. for making the inferencing. So, the edge computing, once the IoT device sends the data to the edge using this model, that is machine learning trained model, it will be able to do the inferencing, and thereby it will be now used for business intelligence and many other functionalities. So, let us go ahead and see the development in this particular direction, that is how the cloud is being provided, the services with the help of cloud data center, and how the edge will provide these functionality with another type of data center, that is called edge data center. Let us see all these development in this particular lecture. So, in the next decade we will continue to see the growth in the number of IP connected mobiles and machine to machine devices, which will handle significant amount of this IP traffic. Now, tomorrow's consumers will demand the faster services and the application delivery for online providers. So, there are some machine to machine devices such as autonomous vehicles. They require the real time communication with the local processing resources to guarantee the safety applications. Here, that is all shown over here, that is these connected devices often are connecting to the cloud for doing various processing. For that it requires this machine to machine devices, they are enabled. So, this IP network cannot handle the high speed data transmission that tomorrow's connected devices is needed, thereby a traditional IP architecture where data must travel often the hundreds of miles over the network, end users or the devices is no longer be the appropriate model, because this results into the latency and slow delivery of time sensitive data. So, this particular model is deviating, that IoT is sending, these connected devices are sending their data to the cloud for streaming, and it, because of round trip time, it is giving the latency and slow delivery of time sensitive data. So, thereby let us see the cloud data centers which are developed around the current demands of the 4G. So, 4G is the technology, communication cellular technology, which uses often the cloud data centers, and the cloud data centers are often developed in support of these kind of 4G technologies. But these applications, this kind of model where all the processing is done at the centralized cloud data center, is not able to support the latency sensitive applications. For example, self driving car, where the latency is more than 800 milliseconds, because it is 400 miles away, that cloud data center where the computing or processing has to be happen. Now, thereby a new kind of cellular networks are coming up, they are called 5G. So, 5G requires these a new kind of data centers which are called micro data centers, sometimes they are called edge data centers. So, these edge data centers are very close to the source, you can see, thereby the data need not have to travel 500 miles, but it is only has to travel 5 miles, and thereby these latency sensitive applications are able to deliver the compute results very efficiently, very fast, and the latency is reduced up to less than 1 millisecond in this particular scenario, where the data centers are brought very close to the source. They are called edge data centers or micro data centers. So, let us see the edge data center, what are the solutions. So, the solution to reducing the latency lies in the edge computing, and thereby you can see in this particular example that these connected devices earlier has to send the data to the cloud, which is far away, that is 500 miles away, but now these connected devices will send the data very close to the device, they are called the edge. So, with the help of edge data center, this is possible to do the computation very close to the source, that is the devices and this can be done by establishing these IoT deployments for cloud based services in the edge data centers. So, whatever cloud capabilities were there earlier now is being enabled at the edge in the edge data centers as well. So, this way these IT resources in the form of compute, storage and the network is becoming more closer to the end user in this technology that is called the edge computing, and this is enabled with the help of edge data centers. So, this helps us achieve efficient high speed delivery of the application and the data. These edge data centers are typically located on the edge of the network. When you say edge of the network, that is out of this cloud and before it connects to the device, that is called the edge. So, this particular example shows that this is the 5G tower, very close to it there will be an edge data center serving. So, these devices has to only being served by the edge data center which is very close to this particular device. So, you can see that instead of bringing the user and the devices to the data center, that is the cloud data center, we bring the power of data center to the users and the devices through the edge computing. So, the edge computing relies on a distributed data center architecture in which the cloud services housed in a edge data centers and are deployed on the outer edge of the network. So, by bringing these IT resources closer to the end users or the devices they serve, what you can achieve is high speed, low latency processing of the data for different applications. So, let us see the edge data center details. So, what you will find is that these data centers, that is the cloud data centers, are also called as a hyperscale cloud data centers, which is a highly centralized set of resources, and they are called as cloud data centers. But these cloud data centers provides enormous amount of compute, storage and network capabilities, but suffers if it is used for computation, it suffers from high latency, high capacity fiber, long term data analysis, archival. For this it is good, but high latency or latency sensitive applications are not good to be computed in these hyperscale cloud data centers. Thereby the edge data centers you can see is out of the cloud and they are very close to these particular devices. So, they are called the edge of the network. So, the data centers away from the cloud, if they are available at the edge of these kind of network, then they are called micro data centers, or it is called the edge data centers, we name it. So, micro data centers are small size data centers, but having the same capabilities as the cloud data centers, and thereby they are able to serve the devices at the local very close by. So, this way of serving the devices with the help of edge data centers, what you will find is that the latency is reduced, or maybe latency is reduced to a ultra low latency sensitive applications in this manner. So, new kind of applications such as smart cities applications and smart business or smart industries, they are possible in this particular scenario, that is with the help of edge data centers. Now, the question is why move these cloud data centers at the edge or at the network edge. So, there are 4 benefits of moving these centralized cloud data centers to the edge, which involve the improvement in terms of latency. Latency will be reduced, bandwidth utilization, bandwidth will be saved, and operating cost also will be reduced, because not every time this cloud is going to be used, and also security will be improved. Why? Because the computation is to be done locally without taking away the data from the local premise. So, thereby let us see one by one what are the benefits if you move the services from the cloud data center to the edge data center. First important development or improvement or innovation is in the terms of latency. So, edge data centers will facilitate low latency, meaning that fast response time is there, and for a time sensitive databases or data applications, this is a very much need. So, locating the compute and the storage functions very close to the end users will reduce the physical distance that the data packet need to traverse, and the number of hops involved will be lower, and thereby the data flow is impaired. So, second importance or second advantage is in terms of bandwidth saving. So, as data center will process the data locally, thereby reducing the traffic which is exposed on the internet. So, reducing the volume of the traffic flowing to and from the central or a cloud data centers, thereby the greater bandwidth across the users broader network becomes available, and it will also improve the network performance. Third important thing is the operating cost, because the edge data center reduce the volume of the traffic flowing from the cloud data centers. They inherently reduce the cost of data transmission routing involved in performing the computation from this cloud. So, this particular way that is called edge data centers is required to see as the high cost saving and also becoming the hub, and which are often giving the services like a cloud, thereby moving the compute and storage very close to the user, and the operating cost also will be reduced in this particular way of running the applications for enabling the computation at the edge. Security. So, edge data centers will enhance the security, thereby reducing the amount of sensitive data which is to be transmitted, limiting the amount of data which is stored in any location, and given their decentralized architecture. Now, third important advantage of the security is that it will decrease the border network vulnerabilities. Why? Because the data will be stored locally, thereby this breach can be ring fenced to portion of the network that they compromise. So, let us introduce the edge data centers. So, edge data centers are the small data centers, they are located very close to the network edge. So, in this example, in this figure, you can see on one end there is a public cloud which is nothing but a provided with the help of a centralized data center. Now, if you move away from this cloud, you will find the network edge, and at the network edge you place a data center, they are called edge data center. These edge data center will serve these devices locally. So, you can see that local devices in a particular premise will require a smaller compute capabilities, not that equivalent to the cloud, but those cloud services, if they are available at the edge or at the network edge, then these devices can be served at the edge data center itself. So, they provide the devices and the applications which is otherwise was processed by the centralized cloud data centers. So, edge data centers can deliver also the cached contents, and the cloud computing resources to these particular devices will be provided. So, the concepts of edge computing, which is nothing but a distributed IT architecture where the client data is processed as close to the originating source as possible, because the smaller data centers are positioned close to the end users, and they used to deliver the services very fast with a minimal latency. So, in the edge computing architecture, time sensitive data may be processed at the point of origin by intermediary servers that is located close to the geographical proximity, and thereby providing the content delivery at the end devices with a very little latency which is possible. So, data that is less time sensitive can be sent to the cloud data center for historical analysis, such as big data analytics for the long term storage, whereas the edge data centers work offline, means off in the same concept, except of just having one server very close to the geographical proximity, and that is the edge data center used to be a small data center. So, this is a new concept that is called edge data center, is a new innovation wave around the evolution of the cloud computing. So, edge data center, let us introduce. So, major benefit is the quick delivery that we have already seen, and thereby the latency may be a big issue for various organizations who are using the Internet of Things and for various compute purposes such as streaming services and analytics or analysis or inferencing services of a machine learning or AI model. So, edge data centers can be used to provide high performance, low level of latency to these end users, making a better experience. So, these edge data center will connect to a larger, that is the centralized or a cloud data centers, or maybe a multiple of other edge data centers. So, this will form a complete distributed environment. So, the cloud will turn into a distributed platform with the help of this edge data center. So, in this particular architecture, data is processed as close to the end user as possible, while it is less integral to the time sensitive data that is sent to the central data center processing. So, you can see here in this particular illustration, there is a cloud data center, but as far as the devices are concerned, devices can directly be reached to the edge data centers, and those kind of capabilities of a cloud are mimicked in the edge data center. These edge data center will be connected close by with the other regional data centers, and finally these regional data centers are connected in the form of with the cloud data centers. So, you can see there is a distributed way these data centers are organized and thereby able to do these computations. The use cases of edge data centers is first of all in the 5G. So, 5G is having a decentralized cellular network made of the edge data centers and provide low latency use cases in 5G. So, these are the telecom companies which requires this edge data center usage. Second is called IoT application. So, edge data centers can be useful for computing these IoT devices. So, IoT devices are now able to connect to the edge data centers instead of directly connecting to the cloud data centers, thereby not only it is having low latency, but also it will improve the scalability, and it will turn the cloud, which is highly centralized, into the distributed environment for doing this processing. So, IoT will be major beneficiary of these edge data centers. Healthcare is also other applications. Autonomous vehicle is a new kind of applications which is only possible to be supported with the help of edge data centers, because the edge data centers is used to collect, process and share the data between the vehicle and other networks, and if the network is at the edge. So, this kind of computing which is required to run the autonomous vehicle will be done very close by. Now, scalable computing at the network edge. So, what we have seen is that evolutionary changes have occurred in the distributed edge and the cloud computing over the last 30 years, that is called the evolution and innovation. So, this is driven by these applications which is of variable workloads and sometimes requires the low latency use cases and often considered with the large data sets, for example artificial intelligence use cases. So, these evolutionary changes are very much needed in the architecture of the cloud, which is highly centralized to support these kind of workloads through the network connectivity, operating system platform and the machine architecture. So, thereby development, that is converting the cloud which is highly centralized into the decentralized or a distributed. So, it introduces the concept of edge computing. So, edge computing uses multiple computers at the network edge to solve the large scale problem locally over the internet. Thus, distributed edge computing becomes data centric and network centric. The emergence of distributed edge computing clouds demands high throughput computing built with the distributed computing technologies. So, this is possible with the innovation in the chip manufacturers, such as the chip manufacturer companies which are manufacturing CPU, GPU and FPU, various other type of accelerator processors at a lower cost and with a small size, which can be now equipped at the edge data centers or edge cloud. Now another thing is called high throughput computing clusters, which supports the peer to peer network edge, and also to support the future Internet of Things. So thereby let us go ahead looking into the cloud model of computing. So cloud computing started with very hype, and in 2009, if we trace back, Gartner has forecasted about the technology which is called a cloud computing. So Gartner in 2009 predicted that cloud computing revenue will soar faster than expected by 2013, and it will represent 19% of entire IT spending by 2015. IDC in 2009 also has hyped about the cloud computing, saying that the spending on IT cloud services will triple in the next 5 years. For Forrester in 2010 also hyped about the cloud computing, that it will go from 2010 to 2020 in many folds of increase. Companies, even the government organizations, were also very hopeful about the usage of the cloud for their usage. So thereby it has given the rise to many cloud providers to come in this particular business and take over this kind of opportunities of innovation. So the companies like Amazon, Google, Microsoft, Salesforce, EMC, Gigaspace, Tengen, DataStax, Oracle, VMware, Yahoo, Cloudera, and many more companies whose icons are shown over here, they started building their cloud and providing these services. Now how the cloud is giving the services is in a following manner. We will discuss one such use case, that is AWS, that is Amazon Web Service. All other cloud providers are also following the similar kind of offering from the cloud. So AWS provides 3 type of services. The first one is called EC2, that is Elastic Compute Cloud. It is nothing but in the form of virtual machines. So virtual machines are offered to the users on pay as you go by, pay as you use. So it is not like physical machine where you have to purchase upfront whether you use it or not, but in the virtual machine, that is the cloud will also provide you the same virtual machine, that is with a processor for compute, memory for storage, and the network for communication. So that is called Elastic Compute Cloud service, that is called virtual machines. AWS also provides a storage service which is called simple storage service called S3. So S3 is used for object storage. So the storage service is being provided. For example, the amount of storage which you use, you have to pay in this particular service. Another type of service which AWS provides is called Elastic Block Storage. This is the storage which is required with the virtual machines or with the EC2 instances. So these are the different type of cloud providers and different type of offerings which are being given by these companies. So thereby all these cloud services is divided into 2 different types. One is called public cloud, which is being provided by the companies like Amazon, Google, Microsoft, for anyone. The other type of cloud is called a private cloud, which is being set up in the similar manner at the premise owned by the company, and it is only used by the company employee, and it is not public, it is private. So there are 2 types of cloud which is possible. One is called public cloud, which we have seen in the previous slide, and the private cloud. Now public cloud provides the service to any customer who want to use it, and for that he has ready to pay the usage. So the examples which we have are telling you about Amazon S3, that is simple storage service. So it provides the storage services where the users can use the storage to store the data set, and the user has to pay per GB per month of storage which it is using through this Amazon S3 service. Similarly, imagine EC2, that is elastic compute cloud, is also another compute services which is possible in the form of virtual machines. So, wherein the user can load their operating system images and they have to pay per CPU hour usage. Third type of service which is provided by Google App Engine, that is also called a compute engine. You are not given the virtual machines, but the entire platform you are given, and you have to use the programming language like Python or some other programming to build your application and upload your data, and it will allow you to run, that is called the platforms. Now, using why the cloud is becoming popular is that the customers are saving both time and money. So, let us see how. For example, if you instead of buying upfront a new machine which takes a lot of time in market survey, giving the purchase order and spending money upfront. So, what you can do is you can save the time by taking the services that is called virtual machines, that is through EC2 instances you can take, that can be available instantly, and also so you thereby you are saving the time, and also money is also saved. For example, if you are not going to use for a longer time that physical machine, then that particular service or service which is being taken by the cloud in the form of a virtual machine will be saving the money. So, a lot of startup companies, they start their businesses by harnessing the large computing resources without buying these kind of machines or hardware upfront, but rather they are being supported by these cloud offerings of compute, storage and network. So, let us see what is the cloud. So, advances in the virtualization has made it possible the growth of these clouds, that is called internet cloud, that is called a new computing paradigm. So, thereby this virtualization allows the sharing across multiple clients or the users of the same infrastructure in the form of a virtual machines. So, this particular technology which is called the virtualization technology that is also has made the dramatic difference between developing the software for the millions to use as a service versus distributing the software to run on their PCs. So, let us see that about what is a cloud. Let us trace back the history. In 1984, long back, the Sun Microsystems gave the slogan that network is the computer. So, and in 2008, David Patterson from UC Berkeley says that data set is the computer, and recently Rajkumar Bhaiya from Melbourne, then they say that the cloud is the computer. So, some people view the cloud as the grid or the cluster which changes through the virtualization. These clouds are anticipated to process huge data set generated by traditional internet or the internet of things. Now, what is there inside cloud, how that is all being provided, these services. So, this cloud, if you go inside the cloud, you will see there are two types of technologies which is used. One is called single site cloud, which is nothing but also called as a data center, and this particular data center often house lot of compute nodes which are grouped into the racks, which are shown over here. This is a rack. These racks are now connected together with the networking which is called the switch, and also these racks using the switch, they are connected with the top of with the core switch. So, this particular network topology which connects these compute nodes is a tree like structure, or it is a hierarchical network topology. Now, as far as the storage is concerned, which is the back end of the nodes, they are connected to the network here in this case, and front end will be in the form of submitting the jobs and receiving the client requests. So, this is a 3-tier architecture which runs the software services on it. So, this is called the data center. Now, another way of looking the cloud is that it is a geographically distributed cloud which consists of multiple such sites, that is multiple data centers which are geographically distributed form of cloud, and these sites perhaps with a different structure and services are being organized. So, computing paradigm distinctions is that if you see this particular cloud computing, it often overlaps with the distributed computing concepts, like you have seen the geo distributed cloud, or inside cloud also you can see that the hundreds and thousands of compute nodes, they are connected to the together with the network, forming a full fledged distributed system. So, cloud is nothing but an example or a model of a distributed system, and distributed system consists of multiple autonomous computers having their own memory, and they communicate using the message passing. So, the cloud computing, if you compare with the distributed computing, what you find is that clouds are built with the physical or the virtualized resources over the large data centers that are distributed systems. So, cloud computing is also considered to be a form of utility computing or the service computing. Okay, before we go ahead, let me repeat this particular definition of a cloud computing. So, clouds are built with the physical or virtualized resources, like we have seen, over the large data centers, and they are the distributed systems. So, let us trace back the history of the development of the cloud over the time. Very beginning days, let us say in 1940s to 1960s, what you find is also there was a data center where very big computers were housed, and they were called a data center. Then the time shift came and the trend shifted. There was a paradigm shift from data centers of 1940s to becoming the time shared computer systems, and that was the trend in the data processing industries which came. After the 1980s, this time shared machines also have made a paradigm shift into the clusters and the grids, and after 2012 what you will find is that this is being matured in the form of cloud and the data centers with the help of peer to peer technologies. So, if you see those kind of industries, that is called data processing industries, was there in the beginning and which requires this kind of data centers of a huge mainframe machines, and then came the time shared industries where the machines were through the operating system, they were shared for doing the computations, and then this kind of technology changes, and 2012 you see the advent of data centers and the cloud data centers after that, which was a precursor to the grid computing or a cluster computing. So, if you see this scalable computing trend technologies, what you find is that there is a pattern of doubling period, that is the storage after every 12 months doubles, that is from the of the same cost, the storage after every 12 months doubles, that is the development or innovation in the technology. Similarly, the bandwidth after every 9 months doubles, and CPU compute capacity of after every 18 months they double, and this law is called Moore's law, which indicates that the processor speeds doubles every 18 months. There is another law in this direction called Gilder's law, indicates that the network bandwidth has doubled each year in the past. So, therefore, the bandwidth you can see that it is keeps on growing because of the current demand, and the storage capacity also is going. Today the PCs have terabytes and so on, which used to happen with the supercomputer long back. So, let us see about these particular trends is that most of these operations, when you talk about hundreds and thousands of computing node put into a data center, then most of these management related operations and management becomes automatic. They are called self organized, support, dynamic, discovery, and so on. Therefore, these major computing paradigm are composable with quality of service and service level agreements. So, the cloud, if it is providing the utility computing, towards utility computing, it has to govern with the quality of service and service level agreement, then only the customers will be using these kind of services with these kind of guarantees. Let us see that these are the newer developments. So, let us see what are the features of today's cloud. So, there are 4 features which are now there in today's cloud. The first one is called the massive scale. So, massive scale means that it is cloud, today's cloud is to be seen as the highly centralized set of computing and storage and networking resources, and often they are called very large data centers. So, these large data centers often house tens to thousands of servers, and to connect these servers you require a huge amount of networking and storage and all these particular things, and therefore, your application will also scale, because these number of servers you can keep on adding, and therefore, this size is called the massive scale, and that is the characteristics of today's cloud. The second thing is that these highly centralized resources, that is compute, storage and the network, often is given on demand access. So, that means pay as you use, there is no upfront cost of usage. So, on demand access is to be provided with the help of technology which is called the virtualization, and we will see this is another characteristics of today's cloud. Third important characteristics of today's cloud is that it supports data intensive nature of computing. So, what you will see is that the workloads which was earlier in the megabytes now is turned into the terabytes, petabyte and zettabytes, in the form of, let us say that if you are doing this daily log analysis or a forensic analysis or a web data analytics, then this kind of workload is categorized as data intensive nature of computing. There is a paradigm shift from the earlier way of computing, which was more on compute intensive nature of a computing, where supercomputers and all that things was earlier the need, but now it is a data intensive nature of computing, and that is the feature of today's cloud. And also the cloud programming paradigms also supports the programming in this particular model, that is in the form of the data centers, and to support on demand access and data intensive nature of computing, you require you to see a new kind of cloud programming paradigms such as MapReduce, Hadoop, NoSQL, Cassandra, MongoDB and so on. So, what we have seen so far is that there are 4 features I have discussed. They are massive scale, on demand access, data intensive nature of computing and new cloud programming paradigm. Now, if one or more of these combinations are available, then it is called the cloud computing problem, and if they are missing, then it is not a cloud computing problem, it is a normal computing problem. So, we will go and see the details of each and every feature which is present in today's cloud. So, let us see the feature which is called the massive scale. In that massive scale, what is seen is that the number of servers in 2009 in the Facebook cloud was 30,000, and which was grown to 60,000, just double after 1 year, and in 2012 it was 180,000 servers were there. So, that is the scale which is called a massive scale. Microsoft uses 150,000 machines, and which are growing at the rate of 10,000 machines per month. Yahoo, if you see, in 2009 it used 100,000 machines, which are split into the clusters of 4,000. Amazon EC2 uses 40,000 machines in 2009, and eBay was using 50,000 machines in 2012, and HP was using 380,000 machines in 180 different data centers. Google is using a lot of these machines, that is called massive scale. So, if you see inside the data center, you will see a lot of racks, and the racks are having lot of servers running within it. So, so this particular data center, which is storing or which is housing, these are called racks, and inside racks you will see these are the servers, and each server will be will look like in this manner, that is called the rack server. So, this particular rack is having this network that is called top of the or top of the rack switch. This is called, they are sharing a common switch and also the common UPS or the power supply of a rack is being shared across these lot of servers, and these top of the rack switch is now further connected with together they are connected with a complete core switch, and core switch is now connected to the internet, so that the client request can be received and being computed over here. So, this entire infrastructure is virtualized, so that this can be shared by different clients in this particular manner. So, if you see this huge data center which is having hundreds and thousands of machines, which requires a cooling and this kind of power supply infrastructure. So, power and energy are the two important major requirement for running this kind of data centers. So, let us see that the power comes from the powerhouse, that is thermal power stations are supplying this particular power. So, there is a metric which will measure whether the data center is effectively using it or not. So, that is called power usage efficiency. Power usage efficiency is a formula which says that total facility power divided by IT equipment power, and if it is close to 1.11, very close to 1, then if it is, then it is called a low and it is very good. If it is more, then it is not that good. So, this is the metric which will check whether the power is efficiently used in the data center or not. Now, similarly, the so much of power, if it is used in the machines, that is in the form of servers, then a lot of heat is being generated. How to cool this water is used to cool this particular heat. So, there is another way of measuring whether the power is efficiently or effectively used or not, that is called a water usage efficiency or WUE. So, WUE says that annual water usage divided by IT equipment energy, and if it is low, then it is good. So, these are the basic requirements to run the data center, where power and the water is very much effectively required to be used, and these are the metric which we have already discussed. Second feature of today's cloud is called on demand access. It is also called as a service. Called as a service classification. So, let us not go in more detail, and so on demand access means that we are buying the compute resources out of the cloud offering. For example, if you want to use a virtual machine, then you can use the elastic compute cloud feature by paying few cents per hour usage of that particular virtual machine. Similarly, if you are using only the storage, then storage cost also requires a few cents per GB per month. Now, this particular on demand services is being categorized in different ways. The first one is called infrastructure as a service. So, infrastructure as a service is a way of on demand access and is being provided by major cloud vendors, which we have seen, whether it is Microsoft Azure, Microsoft Google, Rightforce, they are all in this kind of business, that is called infrastructure as a service. So, infrastructure as a service is being facilitated with the help of the technology which is called the virtualization technology, and this particular infrastructure as a service is providing the virtual machines. So, other type of on demand access to the cloud resources is called platform as a service. So, here the virtual machine is not given, but rather it is given a flexible computing and storage infrastructure, where the users using a Python or a Java program, they can write the programs, they can develop the program and upload their data, and this program will run on that particular data. And so, this kind of thing is called platform as a service. The example is Google's App Engine. Third type of on demand access which is being provided by major cloud providers, they are called software as a service. So, you can directly get access to the services which is run by the software, such as you might have used Google Docs, MS Office on demand and so on. Third type of feature which today's cloud is having is called data intensive nature of computing. So, data intensive nature of computing is quite deviation from the earlier paradigm of computing called compute intensive computing, which uses high performance computing, supercomputer and message passing interface. But nowadays it is more on data intensive nature of computing, where you have a large data set which you need to store. For example, IoT sensors are sending their data to the data center to store and use the data for training the machine learning models. So, therefore, if the data is stored at the data center, then you have to now bring the compute nodes where the data is stored for performing the computation. So, compute this type of thing is where the compute is to be done very close to where the data is stored, called data intensive nature of computation. In contrast to the compute intensive nature of computation, where the data is small and it goes to that particular compute in the supercomputing model. So, in the data intensive nature of computing, the focus is shift from computation to the data intensive. So, here the CPU utilization is no longer important, is the only thing is that input output thing has to be reduced, IO load has to be reduced. So, now the new cloud programming paradigm is there to develop the program and to use this particular model, that is the cloud data center. So, the programming languages such as MapReduce, Elastic MapReduce, Hadoop, Pig, Hive, they are all developed by different NoSQL, they are all developed by different companies, such as Facebook has developed Hadoop and Hive, Yahoo has developed Hadoop and Pig, Amazon has developed Elastic MapReduce, Google has developed the MapReduce. They are all different new cloud programming paradigm. So, this is a new category, that is a private cloud and the public cloud. These are the offering. If you see that whether you use the single site cloud or you own to have the private cloud, if you want to decide, then economies of the scale can be calculated in this. For example, if you are running if starting a startup company and you want to run your service for, let us say, m months, but your service requires, let us say, that to purchase 128 servers with 524 terabytes of storage to run your organization IT infrastructure. So, one thing is that, so if you purchase these infrastructure, it will cost something in this particular amount, and if you want to run for m months, so this particular cost will be divided by m here in this case. So, it comes out to be this value. However, if you want to lease the services from the cloud and you want to calculate for over m month, what you will find is that if this particular cost of outsourcing is less than owning, then you have to go for the so what is being found in most of the cases on an average, that if you require the storage for more than 5 months and if you require the overall infrastructure more than 12 months, then you can own it. If it is less than that, that is why the startup companies are looking for these cloud services. So, let us conclude in the summary. Let me tell you that in this lecture what we have brought you is about the limitation of the current cloud data centers, and we have also given you the concept of new innovation in the cloud data center, that is called edge data centers, and we have also told you about the cloud, which are how they are being developed as with the help of the concepts of a distributed systems, and therefore we have also seen the characteristics of cloud computing, that is the scale, on demand access, data intensive nature of computing and new programming paradigm. With this, let us conclude this lecture. Thank you.